Hello there. Welcome to the official Philosophy of Cognitive Science podcast. My name is Alex.
And my name is Magnus.
We have prepared a wonderful episode on logical positivism and Karl Popper as they are relevant to the field of philosophy of science. We hope you enjoy.
Shall we do a recap?
Okay, but let's make it a quickie, don't you think?
Yes, let's go down to business then.
Okay.
So, we talked about what science is, namely a systematic form of investigation to acquire the best knowledge possible.
Yes, and science relies on empirical observation.
We also distinguish between science and non-science. Science is empirical research, whilst non-science is not. Non-science encompasses many practices which do not qualify as science.
Yes, and we also have pseudoscience. Pseudoscience specifically claims to be science when in reality it is not science.
Yep.
Okay, so let's talk about today's episode. What will we be dealing with in this episode?
So today we'll be dealing with historical perspectives on how to define science and the key criteria that have been used.
Yes, let me start by explaining the main views that were developed over the centuries with respect to the acquisition of knowledge. So around the 17th century in the British Isles, a philosophical tradition called empiricism became dominant, with many notable figures including David Hume. The empiricist view proposed that all knowledge is obtained through real-world experience and experimentation, rejecting the idea of innate knowledge. Sensory experience is considered both the source and limit of our knowledge.
So most empiricists were from the British Isles. I can imagine a group of empiricists having fish and chips and talking about philosophy centuries ago. Just picture them having an argument about whether they like mushy peas or tartar sauce.
Yeah, well, that's a creative way of viewing it.
By the way, do you like mushy peas?
Yes, I do. Who doesn't? But anyway, we're not here to talk about personal preferences, mushy peas and that. Let's get back on track.
Okay, sorry about that.
Okay, I'm going to talk about rationalism now. In continental Europe, a philosophical tradition called rationalism emerged, proposing that some knowledge is innate and that experience is not the only source of knowledge. Reason also leads to knowledge. These traditions have had conflicting views over the centuries, and one famous rationalist was René Descartes. He was a French philosopher.
Okay, so the rationalists could be seen as a group of philosophers, maybe walking around Paris eating baguettes.
I mean, you can see it that way if it helps you.
So let me clarify this. You're saying that since the 17th century, there's been two major traditions called empiricism and rationalism, with opposing views. Essentially, it is a fish and chips versus baguettes.
Yeah? I mean, it's funny, yeah. We've gone through empiricism and rationalism. Yeah? And now we're going to historically situate ourselves in the first half of the 20th century, around maybe 1920, so. Around that time, a famous group of intellectuals was established in Vienna, which aimed to further scientific knowledge. They were called the Vienna Circle, and they inherited many views from the empiricist tradition, meaning that our knowledge is obtained through observation.
So there was a Vienna Circle, so they were located in Austria. I like to call them the Schwarzenegger Circle.
Hell yeah, that's good.
Were there other groups in other places?
Yeah, there were other similar groups in other major European cities, such as Berlin, forming the Berlin Circle, for example. These different groups of scientists often shared knowledge among themselves to make science progress.
Why did these different circles appear?
Well, I mean, the 19th century was full of metaphysics, with complicated texts, and logical positivists rejected metaphysics and called it meaningless nonsense. They wanted to easily classify statements as true or false. Therefore, they differentiated between meaningful statements which are verifiable and meaningless statements which are not verifiable.
Okay, so the logical positivists, they rejected metaphysics as meaningless nonsense and differentiated between meaningful and meaningless statements using their verification criterion. What were some of the main views of logical positivism, Alex?
Well, the figures in the Vienna Circle propose that science follows a strict procedure to acquire knowledge. This is called the received view of science, following the empiricist tradition of empirical observation. So, in the world, there are many phenomena that science tries to explain.
But still no explanation for why lecture notes are always in hieroglyphics.
Yeah, that's true. What is it with academics and their awful handwriting?
Yeah, I don't know. So tell me more about this thing called verification.
Sure thing, Magnus. So, logical positivists propose verification as a criterion to test whether something is scientific or not. This means that one has to seek evidence to prove that a statement is true. For example, we might hypothesize that all swans are white. So we might also go out and find swans. For our hypothesis to be true, we would have to find white swans to confirm our hypothesis. This is the basis of verification. We collect individual observations of white swans. This swan is white, for example. This other swan is also white, and this one is white as well. So we've seen 3 swans, and with these observations, we can create a scientific theory that all swans are white. We're going from individual observations to general laws using induction. Remember induction? Meaning that the conclusion does not necessarily follow from the premises.
Yeah, so you have a theory. What now?
So now we have the theories all swans are white. We can apply this general law to new observations using deduction.
Okay, so the Vienna Circle proposed verification as a demarcation criterion and defended what is called the common sense view of science, meaning that we collect individual observations and create scientific laws using induction. And we can also apply these general laws to new observations using deduction.
Yeah, exactly. That's correct. Just to clarify, the received view of science and the common sense view of science are being used interchangeably in this podcast.
Okay, got it. So the logical positivist said, if it can't be verified, it's just meaningless nonsense, right?
Yeah, exactly. It's like they were the original common sense police, you could say, with their common sense view of science. One thing, it's important to note that the logical positivists propose verification as a demarcation criterion to differentiate between meaningful and meaningless statements, i.e. the meaningfulness of language, not strictly as a demarcation criterion for science. However, this theory has strong implications for science and how to demarcate science.
Okay, so they proposed it to identify meaningfulness, but it can be applied to science.
Yeah, logical positivists propose that we can verify statements in 2 ways. We can verify some statements directly through observation. For example, we can directly verify that the sun is shining if we leave our house. However, we can't always verify statements directly. For example, when we have abstract concepts, for example, height, we would need to conduct measurements first. So if we wanted to verify that Arnold Schwarzenegger is 188 centimeters tall, we would have to measure his height and then we'd be able to verify it indirectly. Now, moving on, some statements are inherently true. For example, the statement, a triangle has 3 sides, is true by definition.
So some statements can be directly verified, and others can be verified indirectly through measurements. They can also be true by definitions. However, I have a question. As you said, the conclusion does not necessarily follow from the premises. So if we saw a black swan, the conclusion would turn out to be false. Is this the case?
Yes, you are indeed correct. This is what is called the problem of induction. When we use induction to go from individual observations to universal laws, we cannot be sure that the conclusion will still be true when we add more observations. So even if we have only seen white swans so far, there might still be black swans out there that we have not observed. David Hume, the famous Scottish empiricist from the 17th century, already hinted at this, namely that we can't use induction to create trustworthy theories because we have limited evidence, and our conclusion might indeed end up being false.
So induction is not trustworthy when forming universal laws because it is based on probability and not certainty. Could we delve into verification a bit more now?
Yeah, sure. As you know, logical positivists proposed verification as a criterion. Yeah, we've talked about this, but we also encounter another problem with verification. Verification follows the following logic. If this theory were true, we would observe this phenomenon. So if we observe the phenomenon, therefore this theory must be true. This logical structure is an example of an affirmation of the consequent, which is structurally invalid. It's a fallacy, as we talked about in the other episode.
Okay, so we have encountered two main problems with the received view of science so far, both the problem of induction and the problem of verification. These problems make the scientific approach unreliable, and many philosophers have criticized it.
Yes, that is precisely it. One of the major figures that criticised logical positivism was Karl Popper, an Austrian philosopher of science who put forward a different theory. He pointed to the clear flaws of the received view of science. Remember, the received view of science is the view put forward by the logical positivists, and Popper tackled both the problem of induction and the problem of verification.
Okay, so what did Popper propose as a criterion to actually demarcate science?
He practically proposed the opposite to verification. He proposed falsifiability as a criterion. According to him, a statement must be falsifiable to be scientific, i.e., it must be able to be proved false. Statements should also be logically falsifiable.
Why did Popper think falsification should be the criterion instead of verification?
Popper suggested that when we make universal claims like all swans are white, we cannot observe all the swans, so there might always be black swans we have not observed, i.e. the problem of induction we talked about. However, if we observe one single black swan, the universal claim all swans are white is falsified. Additionally, the problem of verification renders verification invalid. However, this does not apply to falsification. So, basically, if you see one single black swan, boom, your theory is busted.
So Popper's theory is saying all swans are white, unless, of course, you go to a goth swan party.
Yeah, exactly, that's fun. So, it's all about staying open to the possibility that one swan might just ruin your day.
Okay, so he proposed falsification, which is essentially the opposite of verification. How could we use falsification to classify statements as scientific?
So, for example, the statement God exists would not be considered falsifiable because it cannot be empirically observed. It is in a sense out of our reach.
So the statement, a divine force which is beyond human understanding, created the world. That's not a scientific statement according to Popper, because it cannot be proven false.
Yes, and other statements might not be falsifiable because they absorb all possible explanations. For example, the statement, everything happens for a reason, can be interpreted to accommodate the theory to any event.
Okay, that makes sense. Maybe we could practice with some examples. Don't you think that would be a good idea, just like as a sort of exam practice?
Yeah, exactly. That sounds good. So let's start. Tell me if the following statements would be falsifiable according to Popper. Let's start with this statement. The Earth is spherical.
Yes, that statement is falsifiable because it can be proven false through observation with the correct instruments.
Yeah, that's correct. Next example. What about there is a hidden energy that controls the unfolding of events and explains precognition?
Well, this cannot be empirically tested because of this so-called hidden energy, so it's not falsifiable.
What about astrology is always accurate, but its effects are subtle and only reveal themselves in ways science cannot detect?
That one is not falsifiable because it accommodates any evidence. No counter-evidence is possible, making it not falsifiable.
You're once again correct. So, once a statement in a theory has been falsified, what does Popper propose that should be done?
I'm not sure. Tell me, Master.
Well, Popper said that after having falsified a statement, the scientific community should discuss which parts of the theory to discard. It's important to note that Popper does not endorse the notion of an ultimate scientific method. He simply argues that science advances by proposing hypotheses, falsifying theories, and having a critical attitude.
Okay, so his theory is more of a guiding principle. It is not all-encompassing. We should adopt a falsificationist and critical attitude, is what he is arguing for.
Yes, that is precisely the point he makes. He further explains that we should not take this critical attitude for granted. The ancient Greek philosopher Thales established the tradition of free thought in Greece. It later disappeared during the Middle Ages, and its resurgence occurred during the scientific revolutions in the modern era.
Okay, so this critical attitude, according to him, has only been predominant in certain historical eras and must therefore be appreciated fully.
Yes, in other words, he said we might enter another 2,000-year dumb phase, you could say.
Oh, I hope not.
Well, okay. Popper also rejected the division of scientific disciplines into different fields as they compartmentalized knowledge disciplines. This is, for example, seen in universities.
So Popper might have said, departments of universities around the world unite.
Yes, that captures his point, namely that these disciplines should not be divided into different departments or fields. But I've got to say, well done overall. You've done extremely well.
Thank you. I think this session has been great. What if we go over everything again to summarize some key points?
Yeah, let's summarize all what we've learned in this episode.
Okay, so we discussed the philosophical movements of empiricism and rationalism. Empiricism defends experience as the sole source of knowledge, whereas rationalism claims that knowledge can be arrived at purely through reasoning, without relying on sensory experience.
That is correct, my comrade.
Then we talked about a movement called logical positivism, which became prominent at the start of the 20th century. They proposed verification as a criterion to determine the meaningfulness of statements, but it can be applied to science. They supported the common sense view of science, where we go from individual observations to universal laws using induction. Then we can use deduction to apply these laws to new observations.
Yes, they said that statements can be verified directly or indirectly through measurement. What else?
Well, logical positivism has two fundamental flaws. We talked about the problem of induction and the problem of verification. After that, we moved on to talk about Karl Popper, who acknowledged the existence of these problems. He therefore proposed his own theory of science, with falsification as the criterion, the opposite of verification.
Yeah, perfect then. We have finished, I think. We hope you've enjoyed this episode.
Yeah, it's been great.
And the next episode is about two more philosophers of science. They're called Kuhn and Lakatos.
And if you don't listen to the next episode, to quote the logical positivist, your scientific career will be meaningless nonsense.
Wow, that sounds quite threatening, I think.
Well, let's hope it works. Anyway, goodbye everyone.
Goodbye, see you.